So trigonometry is based on right triangles. Since all triangles can be constructed from right triangles, one thing we can do when we encounter a non-right triangle, for example in this case here, is we can make right triangles. Okay? Any triangle can be split up into a right triangle by drawing a perpendicular line from the vertex down to the base. Okay? And that allows us to deal with these two right triangles here. So here we have this triangle. We have angle, this side here, a side here, and we want to be able to determine all the lengths and angles of this triangle. So what we have here is we have basically three pieces of information of any triangle will allow us to determine the size and shape of that triangle. So we have on the right hand side here the hypotenuse and an angle. Well, with our calculator, we can convert this angle into a ratio, and we can include the hypotenuse in a ratio and solve the right triangle on the right hand side. So if I highlight here, this triangle can be solved. Now we only have one part of this triangle on the left hand side. However, if we solve the right triangle here, this highlighted triangle, we do have a perpendicular line here. We have this altitude, and we in essence have two angles of a right triangle. We have this angle here is 90 degrees. We have two angles. If we have two sides, if we have two sides of a right triangle, we can calculate the third side, and we have ratios to be able to work out all the angles. So this is going to be our strategy then. So one thing to note, and I'm just going to highlight it here, this note, it is in general an important piece to know that if you have three parts of a triangle, any three parts, you can have, other than three angles, you can have three sides, an angle and two sides, a side and two angles. Having that information allows us to be able to figure out the size and shape of that triangle. Okay, or in other words, we can solve that triangle. So here we have this case where we have two angles and a side. So we do have three parts of that triangle. The problem is it's not a right triangle, so we can't use trig based on these angles and these sides yet. However, we could solve for the third angle. So if this is 70 and 80, or sorry, 70 and 30, this angle in here is going to be 80 degrees. So we can do that by deduction. The other part then is we can take this triangle and we can create a perpendicular line to generate a right triangle. I'm just going to highlight this red triangle on the right hand side here, and we can actually solve that triangle. Okay, so in this angle in here, we know that's going to be supplementary, so that's going to be 60 degrees. Okay, so this is a 30-60 triangle, so I'm just going to say that this length here is going to be half of 19, or 9.5. And then we'll use a decimal measurement for this side here. Although we can get the exact measurement, it's going to be 9.5 times root 3. Okay, and the way I can figure this out is I can set up my ratio. Okay, this is going to be root 3 to 1 is going to be x to, I shouldn't say x, I'll call that a. Okay, this length we'll call a to 9.5, and then we can solve for that length of a. We can also use our trig, so we can say, in this case here, we can work out this decimals approximately, but we can also use cosine ratio. So we can say the cosine of 30 degrees is going to be a over 19, okay, the adjacent side over the hypotenuse, and our calculator gives us a cosine value of 0.866. Okay, working out for A is equal to 16.454, so I'm just going to round that to 45. Okay, so this is approximately 16.45. And again, if you did 9.5 times square root 3, you would get the exact same value. Okay, so I've solved this in two ways. I've used cosines, which I'll highlight here. I use their decimal values. But we also solved it using an exact ratio, which here I'll highlight in green. So this is using exact special value triangles. And because it just happens to be a special value triangle. Okay, and then the blue is the calculator solution. Okay, so I still need to solve for the rest of this triangle. I do need to figure out this bottom side here, okay, which I'm going to do maybe do it a different color. I'm going to do it in black. So this length here I'm going to call B. We do have one side of this triangle, okay, the vertical side, and an angle. So I want to solve for B, and I also want to solve for X. I'm going to solve for B first, and I have adjacent and opposite, or rise and run. That's going to be your tan ratio. That's going to be the slope of 70 degrees. So I need the 70 degrees from my calculator. My ratio is, my slope is 2.7474, so I'm just going to round that to 74. Okay, and then solving for B, I'm going to solve this algebraically for B, so I get 9.5 divided by 2.747 is equal to B, and so 9.5 divided by 2.747, the length of B that we get is 3.457, so I'm going to round that to 3.46. Okay, so A plus B. So our length of A plus B, we're going to work out to our length of X. Okay, length of X is going to be equal to 16.45 plus 3.46. Works out to be 19.907, so I'm just going to round that to 91. You may be off a little bit by rounding errors, and that's okay. So we don't need this degree of accuracy, but as long as you're close to 20, you're doing the right thing. Lastly then, I'm going to solve for X, okay, using, to involve X in a ratio, I have hypotenuse. I'll use the opposite side. So I'm going to do opposite side over hypotenuse. Opposite hypotenuse, that's so, which is sine. So I'm going to use sine of 70 degrees. Okay, so 9.5 over X is equal to sine 70 degrees. Works out to be 0.940. Okay, and again, algebraically solving for X, I'm going to cross multiply. 9.5 divided by 0.940. And I'm getting a value of 10.11. Okay, and again, you don't need that degree of accuracy as long as you're close to 10. Okay, you're doing the right thing.